This week in lab, you guys are going to be performing a neutralization reaction. And that is where you react an acid with a base to make a neutral molecule of water, H2O, and a salt. Specifically, you're going to be reacting vinegar, which active ingredient is acetic acid, with sodium hydroxide to form a water molecule and the salt sodium acetate. The goal of the lab is to be able to, at the end, calculate the molarity of the acetic acid or the vinegar solution and calculate the mass percent of acetic acid in the vinegar. Some important formulas to know are going to be the molarity formula, which is capital M, big M, is the moles over liters. And the other formula that'll be useful is the mass percent formula, which is the mass of the solute, in our case it'll be acetic acid, over the total mass, which will be the mass of the acetic acid plus the water it was dissolved in the vinegar solution you buy from the store, and multiply that by 100%. So those are the two formulas you'll be using a lot of in this lab. So if we look at the lab setup, it's a simple titration, and it's possible that some of you have already performed something like this in your in a previous general chemistry lab, but I'll walk you through what we have. So you are going to prime your burette to contain sodium hydroxide, and you'll be given the molarity of that. So you know what the concentration of the sodium hydroxide you're using is. It's going to be about 0.2-ish molar. Okay, and so that's in your burette. And then in your Erlenmeyer flask, you're going to add 5 milliliters of vinegar. And again, this is an unknown concentration. You don't know what the exact concentration of the vinegar is. So you have your 5 milliliters of vinegar, and you're going to put a couple drops of phenolphthalein indicator. Then you slowly titrate in the sodium hydroxide so it can react with the acid and form water. Okay, so this is kind of a pH scale of the indicator. So phenolphthalein at about pH 8-ish turns a very faint pink, and the more basic the pH of the solution goes, the darker pink it is. Okay. So as you're titrating in, if we take a look and see what's kind of going on in your flask, so in the bulk of the solution in the Erlenmeyer, you've got all those acetic acid molecules. Well, sorry, let's zoom and look at these structures. So acetic acid has this molecular formula, and this is what the structural formula of it looks like, though, which could be condensed down further into this smaller structure that shows no carbons or hydrogens bound on carbons. Okay, so acetic acid is an acid, and acids donate protons. Okay, sodium hydroxide is your base, and it is solid in its pure form, and then it's dissolved in water. Right, so in water, it's just sodium ions and hydroxide anions. Okay? And so bases are proton acceptors. So this OH minus, the hydroxide anion, is going to grab the H plus that gets donated from the acid to create your water molecule. Okay, so if we look back up here, so now we're kind of slightly familiarized with what the structures of everything are. So we have sodium hydroxide here being dropped in from the burette into your solution. And again, in the bulk of the solution, you see all these little acetic acid molecules because it's just the acetic acid from the vinegar. Okay. Once the hydroxide molecule is in the solution, what it's going to do is it's going to combine with one of the acetic acid molecules to form a water molecule, HOH, and that's sodium acetate. So here's my acetate anion, and it'll have a sodium cation there to balance the charge. Okay, so that's the reaction that occurs. So once, if we think about back at kind of this pH scale over here, right? If we have acetic acid just sitting in our Erlenmeyer, the solution is going to be colorless because acetic acid is about pH 5. Okay, we reach the end point when we're fully neutral at pH 7, right? We've converted all the acid into water and a salt, and the salt doesn't affect the pH. So it's about pH 7 where we have reached the end point of our titration, where the amount of ions of hydroxide equals the amount of ions or amount of molecules of the acid that you started with. Okay, but the problem is the indicator starts to turn faint pink around 8. So sometimes it's just like one drop into the solution will drastically change the pH and jump it up fairly high. And so what you'll see is that 1 or 2 drops, the solution will turn from colorless to pink. And you want it to be the faintest pink you can possibly get. And the faintest persisting pink that you can possibly get. And that's when you know you've reached your endpoint. Okay? And so it's at the endpoint where the number of moles of acid equal the number of moles of base. So the moles of, remember, here's our formula. So we have our acetic acid plus sodium hydroxide yields a water molecule, which is neutral, right? And a salt solution, that's sodium acetate. Okay. So, but here's the big takeaway piece of information is once you reach the endpoint, so when you get that faintest pink, you have essentially equal number of moles of base and moles of acid. So remember, the whole idea though of this lab is to determine the molarity of acetic acid, okay? So this is what we need to find, okay? So how can we calculate the moles of acetic acid? Well, first let's figure out if we calculate the moles of the base, because remember, you know the concentration of the base, and because you were using a burette, you can take the final volume minus the initial volume and get the volume delivered. So how do we calculate the moles of the base? Again, you know the molarity and you know the volume, okay? The volume that you're gonna get from your burette though is gonna be in milliliters. So you're gonna have to convert that into liters because the formula for concentration is in moles over liters, okay? And again, so I believe the concentration is about 0.2 molar. So if you started to kind of plug and chug some values in here, you can say that 0.2 molar is equal to the moles of NaOH over, and let's say it took 10 milliliters, roughly, like 10.03 milliliters. Well, 10.03 milliliters, 10.03 divided by 1,000, because that's milliliters, we got to get it to liters. All right, so essentially we have this algebraic formula where it's x over 0.01003, okay? So you just simply multiply the volume in liters, you know, by the concentration over here, and you would get your X, which is our moles of sodium hydroxide. Okay. So that's how we can solve and calculate for the moles of sodium hydroxide. Remember at the endpoint that the moles of sodium hydroxide is equal to the moles of acetic acid because you've just reacted them so that they were 1-to-1. It's completely neutral solution. So you were assuming that the moles are exactly equal. Okay. So once you calculate the moles of sodium hydroxide, now you're ready to calculate the molarity of the acetic acid. Okay. So you can do that because remember again, molarity is equal to the moles over the liters. Okay. So the moles you just found out because we just calculated the moles of sodium hydroxide, and at the endpoint, that value is the exact same number of moles of acetic acid. Okay. So we know what the moles are. And the volume, we have to think back to the initial volume that you're going to put into your Erlenmeyer flask. All right, you're going to use a 5 milliliter volumetric pipette. So you know that the volume is 5 milliliters. So you're going to have to convert that though to liters, right? Because we need it to be in liters. But all you have to do is take the moles of acetic acid and divide by the liters of acetic acid. And that's how you can calculate the molarity of the vinegar. As far as the mass percent solution goes, the protocol has a really good walkthrough at the very end, so it gives you sample calculations on how to do that, as well as the ones that I just went over too. But in the end, remember, at the end of the day, what we're doing is you're doing a neutralization reaction where you're going to react acetic acid, which is in vinegar, like over-the-counter, buy at the grocery store vinegar, with sodium hydroxide to create water and a salt. And your goal is to find the molarity and mass percent of the acetic acid solution.